Standard normal distribution. The word looks very fancy, but what this standard normal distribution is doing is it's helping us calculate some unknown variables. So for example, like in the previous section where we saw if they have given you 75 and then 2.5 squared, and then if they give you probability of getting greater than a is 0.2, we were able to calculate a by doing inverse normal. That was easy because we knew what mean was, we knew what standard deviation was. We were able to calculate this, but the only tricky part that we had is every time it was more than, we have to make it less than and then put it as 0.8, and then we need to calculate it. So this is good. But now sometimes in the exam they are going to give you, they're not going to give you the mean, but they will say the standard deviation. Now if they didn't give you the mean, they have to give you one more information. So they will say probability of something being less than 70 equals 0.2. Find mu. Let's make it simple. Find mu. Now the problem I have, I know the probability of this event happening. I know the standard deviation. So in the calculator, without mu, I cannot enter anything. So let's just figure this out. In the normal distribution curve, mean is in the middle. Agree? Less than 70 is 0.2%. So this, let's say this is 0.2. Like the area is 0.2, by the way. I also know this value is 70. So less than 70 is 0.2. Yes. But I don't know mu. If I need to calculate what's mu, I can't use this curve because mu is unknown. So let's keep this to a side. Every time mu is unknown or sigma is unknown, standard deviation is unknown, you draw another curve. So draw the curves from now onwards, draw the curve for every question that they ask. Then your understanding would be much better. Draw another curve. This time you put your mu as 0. We did not know what mu was. So for the new curve, you call it 0. If you call the mu as 0, the sigma will become 1. So what we did basically is, I did not know this, so let's scrap that. And then let's form another distribution called a standard distribution. A standard distribution means we're trying to think if there is another one that exists exactly like this, another one existed, another one existed, it would look like this. So I've just put it as Z. Z is a standard distribution sign. So every time you see Z, that means standardized form. And mean is 0. Standard deviation is 1. So 1 squared. Now I know 0 and 1. And what they gave us is this. This information is what they gave us. But that was X. What I have is Z now. I'm trying to change everything to a Z. So I'm just going to change probability of X less than 70 equals 0.2. Do you agree that I can't go and put this, like this point here, I can't put that as 70 because I've changed this variable to a 0. So I need to figure out what variable is this now. And I know the area is going to be 0.2. The curve stays the same. Area stays the same. The only thing is I've just coded the information of mu as 0, standard deviation as 1 squared. So I have to find an equivalent value of 70 in Z. In this Z, how would this 70 be? So let's say I don't know. because I don't know. By looking at the curve, I don't know. What 70 could have transformed into, I don't know. So let's just say Z less than, let's say A for now. This is A. A equals 0.2. But what I know is, I know mu, I know sigma, I know this. Can I use inverse normal to figure out what A is? So in the area, just put 0.2. In the mu section, put 0. In the sigma section, put 1. Be careful, the sigma and then the mu is the other way around in the calculator. So we get minus, and don't get scared by looking at a minus. Can I get even this answer? Yes, we can, because this is the standardized value, not the actual value. So what is the equivalent value of 70 is minus 1.2816. Then this standardized Z has a formula that you need to memorize. But it's in the formula booklet, and I'll show you where in the formula booklet as well. It's in the formula booklet, but you have to actually go into the further math section to look for it. It's not in the normal math section. So Z equals X minus mu over sigma. That's the formula. It's not that hard of a formula. It's just X minus mu over sigma. We know what X is. X was 70. What transformed is 70. Do we know the mu, the actual mu? No. Do I know the standard deviation? 2. So I'm just filling it in. Do I know the standardized value for that 70? Yes. 1.2816. We know the standardized value of that 70. We know X is 70. We do not know mu. I know sigma. All I need to do is just rearrange it. I know mu now. So minus 1.2816 times it by 2 equals 70 minus mu. Then mu equals 70 minus 1.2816 times it by 2. $72.56.